This video is going to go over rules for balancing equations. So if your equation hasn't been completed, you just have your reactants. One of the first things that you have to do is you have to make sure that when you create the compounds, the products, you make compounds that actually exist. So if the compound is ionic, the charges have to be balanced by subscripts, right? So they have to create an electrically neutral compound. So for example, calcium chloride would be CaCl2, not CaCl or Ca2Cl. And water is not HO, it's H2O. Then you have to balance the equation. And remember that when you're balancing the equation, you can only change the coefficient, the number in front of the compound, and that coefficient applies to the entire compound. And then there's an order. The order usually goes, you do your metals first, then your polyatomic ions, especially if they remain grouped together, then your non-oxygen and hydrogen nonmetals, then hydrogen, and then oxygen, and then of course you check. So we're going to do a couple of examples, keeping that order there. So the first one is going to be Al plus F2. And we're going to first figure out whether or not you can figure out what kind of reaction this is. So I'm taking two elements. The only thing I can do is really smash them together. So this is a composition or a combination reaction. Al is a metal, so I have to remember that I'm going to create an ionic compound. So when aluminum and fluorine combine, aluminum takes a +3 charge and fluorine takes a -1 charge. So I'm going to need 3 fluorines for every aluminum. So my compound is AlF3. And I created that with the subscripts. Now I balance with coefficients. My metal, aluminum, is already balanced. So now I have to balance my fluorines. So if I have a 2 on one side and a 3 on the other, I balance by least common multiple, which will be 6. So I put a 3 in front of the fluorine here and a 2 in front of the aluminum fluoride here. I multiply my coefficient times my subscript to check. So I have 3 times 2 or 6 fluorines here and 2 times 3, 6 fluorines. So my fluorines are balanced. But now this is unbalanced by aluminum, so I have to go back and multiply my aluminum reactant by 2. So I check. 2 aluminums, 6 fluorines, 6 fluorines. Check. Next reaction. This next reaction, I have a reactant and oxygen gas. So if you guessed combustion reaction, you're right on. So this is my A and this is my B. So a combustion reaction will always create AO2, or in this case CO2, plus B2O, or H2O. Now that I've created compounds that exist, I now balance. I don't have any any metals. All I have are nonmetals, and my only non-hydrogen and oxygen nonmetal is carbon. I have 3 carbons here and nothing here, just 1, so I have to multiply this carbon dioxide by 3. Now I balance my hydrogens. I have 8 hydrogens here. I have 2 here, so I multiply this by 4. So 4 times 2 is equal to 8. 3 times 1 is equal to 3. So now I look to my oxygens. I have 6 oxygens here and 4 oxygens here, for a total of 10 oxygens on my product side. So I need 10 oxygens on the reactant side. So I will get that by multiplying this 2 by 5. So double check. 3 carbons here, 3 carbons here. 8 hydrogens here. 4 times 2 is 8, so 8 hydrogens on the products. And then I have 6 plus 4, or 10 oxygens on the product side. So I multiply this by 5 to get 10 here. Next reaction. What kind of reaction? I gave you the products. So I have one more complex reactant that is now broken down into smaller products. So if you guessed decomposition in the presence of heat, you were right. So let's balance this. Carbon. I have 1 carbon here, 1 carbon here. 2 hydrogens here, 2 hydrogens here, 3 oxygens here and 1 plus 2 or 3 oxygens. So actually this is balanced. So sometimes you come across a reaction that is already balanced. They don't need any sort of coefficients other than 1, and you are lucky. So this is the most complex kind of reaction that you'll probably have. These are two aqueous ionic compounds. So if you guessed double replacement, you are correct. So the final reaction is a double replacement reaction. And so my metals are going to switch partners, but I have to create something that actually exists. So lithium takes a +1 charge, the phosphate ion a -3, copper is +2, and nitrate is -1. So when my lithium combines with my nitrate, I'm going to create lithium nitrate, and I don't need to add any subscripts because they both take a positive and -1 charge. And then copper and phosphate, +2 and -3 means I need 3 coppers for every 2 phosphates. So I've made compounds that actually exist. They're ionically neutral. So now I have to balance. So I have copper. I have 3 coppers on this side and 1 on this side. So I will multiply this by 3. I have 3 lithiums here and 3 lithiums here. Now I look for my polyatomic ions. I have 2 phosphates here, so I have to multiply this by 2. And I have 6 nitrates here, but only 3 nitrates here, so I have to change this to a 6. Now I double check. So I have 6 lithiums. Now I have 6 lithiums. I have 2 phosphates right here. I have 3 coppers right here, and I have 3 times 2 or 6 nitrates here, and I have 6 nitrates here, so I am set. And there you have it.